All right, lesson set 31. I'm going to do things a little bit differently in this lesson set than previous lesson sets. The first 40 problems from lesson set 1 to 25 basically deals with algebra 1. We had to close gaps from previous levels of study. We've spent 2 months doing that, and now it's time to move on. You will still be tested on those questions. But this is a 107 question lesson set. And so we'll do 2 days of testing, odds and evens. We'll do the even numbers one day, the odds the next, and we probably won't test for another 2 weeks. All right, so we'll get the new material, which is lesson set 26 to lesson set 25 to 30, something like that. All the new material for the semester has been presented there. And now we're just going to practice. So I won't be offering too many explanations as we go along. This is going to be roughly 67 problems, I guess. So I'm not going to talk about them too much because the discussions have happened in earlier lesson sets. So problems 1 through 40 are on you. You're still going to be tested on them, but they're just going to have added here. And some of the newest material I will still talk about. All right, but otherwise just going to go to work starting now. I guess I'll show you all the problems. There are 5 here. You can pause the video and look at the 5. They look pretty familiar to me, obviously. And yeah, I'll just take a trip around the room. All right, and you can just see what you want to work on in case you don't want to work on everything and you feel pretty confident. I don't offer many instructions because you look at a problem like this and you've done the earlier lesson set, you know I'm asking you to write that as a product. Difference of 2 cubes. Right, there's name those tunes. We do that a lot. Name the graph. I'm using WAAP now as write as a product. I think that, we always say factoring, but if you ask a student what's factoring mean, you don't really hear writing sums and differences as products. So I'm going to say write it as a product. All right, we've got some newer material. We're going to be graphing these, doing some more trig. So I'll, I'm assuming that you've done the introduction to the unit circle. You've looked at that video. So just going to go at it. We've got, boy, a lot of problems to do here, but we're going to do them quickly. Write as a product. All right, should be a very familiar problem without me even. You know the drill. If you don't know the drill, YKTD, you know the drill, then you haven't done the earlier lesson sets. All right, and then writing graphs quickly and easily, hopefully. Solving some trig, rules of logarithms, some functional notation. And then we've got our graphs. And I've still got another 5 graphs after that. On the back side of that, I'm not going to move it now because we're going to go back with Rennie the cart. And we're going to get through this lesson set in hopefully 40 minutes. 67 problems in 40 minutes. I don't know if I do explanations, if that's possible. But, if you're taking a test, I'm hoping you can do these 67 problems in a half an hour. All right, so let's have at it. I'm going to get an eraser. I got one. And there's nothing new here that I can see. So E squared over E is E. And this is asking us to find the exponential activity on top of E. Oh, well, I have base E, and I can see the exponential activity is a -4. All right, so that problem's done. 2x plus 2 over x minus 3. When's it greater than 0? Well, we have sign changes to the first power, both of them. At 3, a sign change, and at -1, a sign change. Which means that if I can figure out numbers bigger than 3, whether it's true or false, then I know it's going to be false and true. And I know that's going to be true just by looking at it, because if I put 1,000,000 in here, I get a positive numerator or a positive denominator, and that's greater than 0. So true, false, true. All right, get rid of that one. I hope that I don't have to rewrite these. I'm not going to make a mistake. So this is it. If I make a mistake, you're going to watch me look at it. If I start to lose cognitive ability at the end of this, hope not. All right, so I'm going to divide 5 into that. I get -2. I'm going to change that to 1/3. That's the base. That's the exponent on top of it. And that gets us 1/9. That's the answer to that one. Remember, you're pausing the video. trying these problems on your own. I'm going to change this to a hypotenuse of 5. That's our 30, 60, 90. Those are our ratios. This is going to become 5 times bigger. Then so is this. And so is this. Okay, so there's a 2-to-1 ratio here, right? 2-to-1. So this becomes 5/2. Right, so all I have to do is double or divide by 2. And this one becomes 5/2 root 3. Root 3. 1.73 times bigger, roughly, than that. This is 1.73 times bigger than that. And this is half of that. Okay, so multiply by 2, and you get the hypotenuse, which is the longest. Multiply by 1.73, you get the middle length. Good for your SATs. All right, so just going to write this using the cube roots. 4m plus 3n times, square this, 16m squared. Change that product to a negative, minus 12mn, and then square that, 9n squared. Remember, explanations are coming from the earlier lesson sets. Write as a product. First rule of products, take out what's common. 2 times x squared minus 3x minus 18, which is 2 times x minus 6 times x plus 3. Okay, so that one's done. All right. I like to do columns, so I've got 8x cubed. I've got minus 10x squared. And I've got 2x. Now I'm going to multiply that. I got minus 15x to the 4th. Minus 15x to the 4th. Next, it's got some cubes. Positive 6x cubed. Oops. Positive 6x cubed. Not the best lining up here, but that's okay. Minus 3x squared. All right, now we can put it together. Minus 15x to the 4th. 8 and 6 is 14. X to the 3rd. Minus 13. X squared plus 2x. Yasser, you got to back me up here. I'm probably going to make some careless errors. Let's hope not. All right, so I'm going to take the square root of 64 and flip it. So in essence, I have 1 over 64. That takes care of the minus sign. 1/2 means square root, and that's 1/8. And that's done. All right, so I know 9 times 6. Ooh, wait a minute. So 27 times 2. Okay, so this is equal to the cube root of 27 times 2. Took me a little while for that. X, that's probably a Y. Probably copied it wrong. So now this becomes 3 times the cube root with the 2 in there. Let's put that 3 over here. Let's see if I have enough room for X, Y, Z. The cube root of x to the 12th is x to the 4. 4 times 3 is 12. The cube root of y to the 3 is y. The cube root of z to the 29, 3 goes into 27 9 times with 2 left over. Okay, so I think that's done. Next problem. Square root of 6 times the square root of 6 times the square root of 3, that's the square root of 18. Plus the square root of 6, which is the square root of 2 times the square root of 3, times 5 root 3, and square root of 6 times the square root of 6, which is squaring that. So final answer, 3 times 5, 15, 3 times 15 root 2. This one over here is 6 root 3. And this one over here is 6. So I don't have any like terms. Got to leave it like that. All right, so that one's done. That whole thing is done. So let's move on, save time here. All right, I questioned whether or not I really wanted to ask this question. That's a -8 here. All right, so what do we have? We have add 8, 48. Divide by 20. 4 goes into 25 times, 4 goes into 48, 12 times. All right, so that takes care of that and that. 1/2 to the becomes log base 1/2 of 12/5. I'm going to multiply that by 6. Then I'm going to add 5. And I do not give you a decimal approximation for that because I don't know what it is myself. All right, so it's going to be a negative number here, this log, right? Because it's flipping, and that's close to 2. So we're kind of close to -1, a little more than -1, -6.5 plus 5. I'm guessing minus 1.5 if you did it in a calculator. All right, that takes care of that. All right, so this one is undefined. So let's just use an offset symbol. It's undefined, 9/2. So the pi over 2's are here. The odd pi's of 2 are here, and I've got 9, which is going to be here. 9 pi over 2, right? 4 and 1/4 revolutions. 8 pi over 2, 4 pi, 2 pi, 4 pi, and another half. Straight up, no width, height of 1, hypotenuse of 1. 1 divided by 0 is undefined, right? Height, width. All right, so that's undefined. The fraction is undefined. We'll talk more about that tangent function as we go through the term. ln of 27 is equal exactly to 3 ln of 3. I'll explain that more in a moment, which is approximately, and I asked for an approximation, 3.3. Okay, so 27 is 3 cubed. In E notation, 3 is e to the 1.1 approximately 3, and this is looking for the exponential activity. Power to power is multiplication. There's your 3.3. All right, I forget what I asked. Let's say we want to double something every, let's see, double something with a 5% interest rate. Okay, so doubling something means I have let's say $200, 100, e to the 0.05t. Okay, our answer is going to be the ln of 2, that's the doubling exponent, divided by the interest rate 0.05. So that's 0.7 over 0.05. Let's multiply by 100 and 100, which I hope I don't have to write again, because all you're doing is changing the decimal place 2 places to the right. And so that looks like it's 14 years. All right, so how did we do that? We divided by 100. There's our 2. E to the 0.05t, which obviously has to equal e to the 0.7t, right? That's the doubling function. All right, so what do we have? We've got the ln of 2. That takes care of that. We got to divide by 0.05, and there's our explanation. All right, so we're done with that. All righty, getting back to erasing here. This is the exponent you put on top of e to get 17. Oh my, it's on top of e. That gets us 17 times 2. Minus 2 times, I am looking for the exponent I put on top of, what do I put on top of e? I'm not saying this well. All right, so this is e to the what equals e to the 17. Obviously, that's 17 as well. So we have that, and our answer is 0. So what we're after is inverse operations, and that's just a little more perspective on the problem. I'll erase later. X equals -1. That means we're going to write this as a product. X minus 1 times what gets us x cubed? Well, that's got to be x squared. Now I have minus x squared. I need minus 4x, because that gets me minus 4. Minus 3 is what I wanted. Excuse me. I want to get to 4. Almost made a mistake there. All right, so there's minus x squared. There's minus 3x squared. I need x. Right now I've got 3x, and I want 1x, 3x, so minus 2. Minus 2 times minus 1 is not 6. So did I make a mistake in writing the problem, or did I just make a mistake here? So let's go back to this. And maybe I didn't ask, because it can't be a remainder. If that's a root, find the other roots. Well, it can be, actually. I just have to, I was hoping to give you a factoring problem. Maybe I didn't. So this is minus 3x, but I usually don't ask you to complete the square with an odd number. So let's see what we get here. So now I've got plus 4x squared. I wanted minus 4x squared. Oh, minus times a minus. So this is my mistake. All right, I found it. Minus x squared, and I need minus 4. So I need another 3. Yeah, no, I was fine. That's correct. All right, so that's right. Yep. And now I've got positive 3x. I got to get that to be minus 2. Oh, okay. Now that's not factorable that way. And I want a positive. All right, so we'd have to do the quadratic formula or complete the square. And I wouldn't ask you that at this stage. So can I change this quickly? Yes, I can. So -1 times -2 is +2. Let's just do that. And I think I've changed the problem so that we can look at this now and say a +2. So what is this? This one is x minus 1. So that's a double root here. And x minus 2. And so we've got a double root oh, that's -1. So our other roots are 1, 2. All right. Yeah, let's just take a quick graph of that cubic, see what we know. X plus 2 is going up at 0 and about 1 to 1, and that's 0, 2. This term here is going to give us a little bend. Okay, and so I guess it does this. I guess if we put that in there, so we should get a point of inflection a little bit smaller than, what was this one? 1. A little bit small. So let's do minus b over 3a. Minus b, 4 over 3 times 1 is 3. That's a little bit more than 1. All right, so I guess it did this. A little bit more than 1. So the point of inflection's here. So it looks like it came here a little bit lower and then up. That's my guess. All right, if I need to do more than that, it's going to take up too much time on the video. I'd have to do that on my own dime. All right, so that's done. At least those are the processes that you take. 7 pi over 4. So we got the circle. We're going to break it up into 4 parts, which means we got another 4 parts here. This is 7 pi over 4 here. The tangent is minus root 2 over 2 divided by root 2 over 2, and that divided by that, -1. All right, let's get rid of that for some space. And I'll try to do it quickly. So we're going to look at the critical numbers and find out if we can use numbers or not use numbers. So 6 is critical. 10 is critical. Can I use numbers bigger than 10? No, I do not want square roots of negatives. Are not going to show up, Rene Descartes. So false. So no, cannot use. Can I use 10? No problem there. That gives me 0 divided by 4. I can do that with a calculator. So yes. Oh, yes, here. Can I use numbers between 6 and 10? Well, let's use 7. 10 minus 7 is the square root of 3. 10 minus 6, what did I say? 7 minus 6 is 1. No problem there. So yes, we can use these. Can I use numbers like 6? 6 minus 6 is 0. I don't think I can divide by 0, so no. Can't use 6. Can I use numbers smaller than 6? Smaller than 6 means I'm dividing by a negative. Smaller than 6 means I have a positive square root. I see no problem with that, so yes. So how is the best way to write this? Negative infinity to 6, union 6 to 10. And 10 I can use, so that's a bracket. And that's your interval notation, which is used to describe intervals. How nice. All right, better get your pencil ready, Yasser. I got a feeling that this pace, who knows? All right, rate of change. So I've got x1 and x2. So finding slope, e to the x looks like this. And I'm looking at the average rate of change from -1 to 2. Boop, 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 boop. I'm finding that slope. And so I've got to do e to the 2, positive 2, minus e to the -1, all over 2 minus a -1. All right, and I'm not going to ask you to do much more than that. E squared is around 7 something. All right, so I'm not even going to mess with it. That's what you got to do. You got to find the slope. And that's an algebra 1 question right there, except for the fact we're using E notation. But I wouldn't be afraid to give that in algebra 1 because it's just slope between 2 points. All right, 2 cosine x plus 1 equals 0. We're looking for where the widths in the unit circle are equal to -1/2. All right, so we've got the unit circle here. When widths go to 1 to -1, so I am halfway right there. What's that look like to you? It sure looks like a 60-degree triangle to me. All right, both of those are 60-degree reference angles. So what gives us 60 degrees? That gives us +1/2. We want -1/2, bring the 1 over, divide by 2. And so we want the cosine of what angles give us that? 120 degrees, and 60 plus 180, 240. But of course, I'm going to want you to write that as 2 pi over 3. And I want you to write this one as 4 pi over 3. All right, we're going to get a lot of practice with that. Nobody's testing you for a couple of weeks. So chill out. All right, next. Oh, that was that. All right, here we go. No need to give explanation here. We got difference of 2 cubes, so it's just a little harder than the earlier one. We got 2x to the 10 minus 5y squared. Those are the cube roots of these. So I got to square that one, which is 4x to the 20. I've got to take this product and change the sign, and that's x10 y squared, and square that. Most of you are already getting those right anyway. All right, pick up some stragglers. So that's gone. Make some room for myself here. Square root of that, it's squared, so 3x minus 3, which looks like negative 1/3 and up that way. 3x minus 3, 0 gets me minus 3, so there's only one answer here. So the bigger answer I'm going to keep, and the other one I'm going to discard. And that's equal to this squared, which is x squared plus 2x plus 1. So 0 equals x squared minus x plus 4. Did I do that again? Adding 3 to 1. I usually try to give you integer answer here. So let me doctor this up so I get something that's nice. Let's make this a 2. Let's make that a 2, so that's going to make that a 4. And then when I add 3, no, that doesn't get it done. I hate doing this. Let's see here. Let me see. 3, 4. Okay, so minus 2. Minus 2, no. See, if I throw a 3 in there, a 4 in there, I get 9. A 4 in here. Minus 1, that should work. Okay, so I must have made a careless error here. Minus 2x plus 1. Okay, so that takes care of that, I think. So I take 3x away, which makes that minus 5. And now I bring it over and I get positive 4. Okay, so that's going to be x minus 4 times x minus 1. Okay, so the minus 1 would have been the fictitious answer this way. That would have been the fictitious answer to get a 0. All right, so I said something wrong. 1/3 though. All right, so I'm lost in my own thoughts here, but your answer should be a 4. 4 minus 1 is 3. 12 minus 3 is 9. Square root of 9 is 3. So 4 worked. All right, because I'm erasing these, I don't want to have to write them all over again. Going to infinity, just the big players, right? X times x, x squared. The same exponents, so those divide out of the problems, and this thing is going to 2. And if you want to fool with it, put 1,000 in there. Put 1,000 in, do the math, and you'll see you're going to be close to 2. All right. You subtract exponents. Logs are exponential values. The only time that you subtract exponents is when you divide quantities. That would be under the 9. That would be 12 minus 3. That's kind of what I'm saying here, 12 minus 3. I'm not doing the whole problem. I'm only looking at the exponential activity. All right, so that means that these quantities must be a quotient. X divided by x minus 1 is another way that I could write this as a single log. And I'm setting that to 1. So I can change this by moving the 4 over, making the base, and that gets rid of this operation. X over x minus 1 equals 4. Now I'll do a little bingo equals bango. So x times 1 is x. 4 times x minus 1 is 4x minus 4. So 4 is over here. 3x is over here. My answer should be 4/3. And I think I captured that so you can see it. You're pausing the video, trying the problems. And you probably have to, at this pace, listen to what I'm saying maybe twice, but I'm not talking about it too much. I got a V-shaped graph that looks like that. I'm decreasing on the left side. So we've already talked about that's going to be 8, comma, 2, 2, comma, positive 1. And I'm going down at 8 to 1. Over here, I'm going up at 8 to 1. That you can look at in previous videos. So Y equals Alfred Hitchcock. Decreasing, -8, parentheses. I'm taking the shortcut now, +1. And that's for X value hinged at 2, less than 2. And I'm going up at 8 to 1, sharing the coordinate X minus 2 plus 1. And that happens when X is greater than or equal to 2. All right. Now we're solving an absolute value equation here. So we're going to do equals right there. Keep your eyes up on that. I'm taking away 25. Boom, it's gone. The 1 is gone. I'm dividing by 2. That's gone. And this positive 24. I knew that was wrong. Positive 24. Take 1 away. Yeah, that was stupid. So that's 12 now. All right, so that's 12. Now we're setting 4x minus 8 to 12. So I'm adding 8, which makes it 20. And then I'm dividing by 4, which makes it 5. So therefore I have 5 as a solution, 2 is the center. And if I've got 3 units in that direction, I can save myself some time. And your answers to this are x equals -1 and 5. All right, if you add those up, you get +4, and +4 divided by 2 is 2, which is your axis of symmetry to your V-shaped graph. All right, so now that I have those answers, this becomes a piece of cake. When am I bigger than 25? When I put a big number in there, it stays positive. All right, so pick any number bigger than 5, and you will say that this is true, and then that's false, and that's true. The other way to do it was to recognize the graph. We had 2, 1, and we had heights of 25 right here at 5, 25, and -1, 25. So these are the y values that are bigger than 25, and they come from these x values and these x values, not the ones in the middle. So I hope you can see that we kind of have a old-fashioned interval notation that you looked at in grade school, right? So what are your answers? -infinity to -1, union 5 to infinity. All right, name that tune. All right, so write as a product. All right, so I'm going to write this as a product. You're pausing the video, and I'm hoping you're seeing what I'm seeing. 3a plus 5 squared. I'm hoping you're seeing that. Oh, -5. I hope you're not seeing what I originally wrote. I needed a negative in the middle. All right, so that was a binomial square. Squares at the end, doubling the product. Want to get good at that. All right, now I can name this too. So what do I see? I see my first y value is 1905. How do I get to 1802? I go down 103 years. Now I can put log. This is a logarithm. Asymptote at 3, so x minus 3. That's a domain restriction. I can only work with numbers bigger than 3. 7 is how much bigger than 3? 4 units. And when I drop an 11 in, I get a base 2. All right, so that's that 2. All right, so let me leave that on the board. Let's erase this. All right, write the equation depicted. You're going to have to learn how to do that if you ever take calculus. Finding coordinates of intersecting graphs and figuring out what the area is from certain intervals. All right, so 0, -5, but I'm going to write this. I'm not going to use 7, 2 as the coordinate. So I'm going to use 0, -5, 2, 7, 2. So my change in x from 0 to 7 is 7 units. My change in y is 7 units. And so that's x minus 0. I don't need to write that. -5, that's the line that's increasing at a 1-to-1 rate. Then I'm going from 7 to 8, which is changing by 1. And I'm going from 2 to -20, which is down 22. And I'm going to use x minus 8 minus 20, x minus 8 minus 20 as my point of focus. I'm not going to mess with that. I just want people to realize that equations are intersections of graphs. Graph 1, the line on it's going up, about we do the up line, and over here we do the down line. And we're trying to find out where they intersect. And we would solve that and get 7, 2. All right. Inverse. So what are the inverse operations if I was solving this for some number? Well, I'd subtract 7 and divide by 5. Checking to make sure there's no careless error. Let's put a 2 in. 2 gets us 17. Down here, 17 should get us 2. 17 minus 7, 10 divided by 5 is 2. Move on. Make some room here. Oh boy, I am not going to do this video again. I hope I don't make a real careless error. 4 is 2 squared to the 3x minus 1. 8 is 2 to the 3 to the x plus 1. The bases are the same, so the numerical activity has to be equal. 2 times 3x is 6x minus 2. Has to equal 3x plus 3. So I got 3x. Over here I got 5, so x equals 5/3. Should be the answer. All right, let's take care of that one. All right, we're going to change this into e notation. So why don't we start here? Instead of 2, let's write e to the 0.7. All right, so now what do I have? I have the rule of power to power, which makes this 20e to the 0.7t over 1,000. We're looking at compound interest here, that type of problem. All right, and so our elementary school math means I'm going to move the decimal 3 places to the right. And so I'll doctor it up and say 20e to the what? 1, 2, 3, 3 decimals, 3 zeros, and a 7 and a t. And that's an approximation for what I originally wrote. All right. Yep. All right, we're going to learn to graph these. At this stage of the game, we're not going to do the true, false, true sign chart. We're going to graph. -1, it's got an odd exponent. So -1 is going to have a change of signs. X plus 3 squared at -3. We're not going to have a change of signs. So I'm going to put a little dot there. And at 5, we're not going to have a change of signs. If I put 1,000,000 in here, 1,000,000 in here, and 1,000,000 in here, I got a strong feeling that I'm going to be greater than or equal to 0. So this is what the graph looks like. Now we're ready to look at greater than or equal to 0. Well, -3 works. So we'll bracket that. Union, -1 works. And all the way to infinity works. That's what I'm seeing. I'm seeing one number works. And then all of these x's from 1 will produce things that are bigger or equal to 0. There's your answer. Okay, one more time. Pause the video, each problem. I'm just going to keep going. -14 pi over 3. Let's do that quickly in my head and see if I get a right answer. I'm thinking -1/2, but let's find out. All right, so pi over 3, 60-degree angles. So let's get rid of that. 60-degree angles, right there, right there. Once around is -6 pi over 3. Then you got -12 pi over 3. And then you're going 2 more checks, 2 more in that direction. And yes, that was -1/2. All right, so let's go over here. We're overlearning this because you got to take everything into the next class. All right, so I got 25 plus 20i. 2i squared is 4i squared. 4i squared is -4. So final answer, 21i, 21i, no, not i, just 21 plus 20i. Okay, so I'm not tired yet. This is good. At this pace, I don't get tired. It's when I try to explain things too many times. Right as a product. Well, that could be a long time here. We got x to the 8 plus 1 times x to the 8 minus 1. Difference of 2 squares. Oh, I see another difference of 2 squares. X to the 8 plus 1 times x to the 4 plus 1 times x to the 4 minus 1. Oh, I spot another difference of 2 squares. I got x to the 8 plus 1 times x to the 4 plus 1 times, oh my God, x squared plus 1 times x squared minus 1. Oh, I got another difference of 2 squares. Last line of work. 8x, I don't think I'll ask this. I don't want to correct it. I don't know how you're going to put this on your answer key. X squared plus 1 times x plus 1 times x minus 1. Okay. So be it. That's done. All right, 3e to the, I can do this going up. All right, so I got to subtract 1. I got to divide by 3. I got to do the inverse of e, which is the ln of -1. Stop there. You can't have it. Can't take an ln of a negative number. We're done. Wait a minute. 3e to the x plus 1 equals 4 is what I said, yes? That graph should go through a height of 4. Take away 1. Oh, divide by 3. Positive 1. Ho, ho, ho. Wait a minute here. ln of 1 is 0. Almost. Almost had to get you in there. And e to the 0. Take 1 away, 3. Divide to big ln. ln of 1 is 0. Oh, God almighty. I shouldn't have even had it done any work, right? I can see 3 plus 1 is 4. Wasn't looking at it. So 0 works. That's our answer. Okay, starting to get to that cognitive decline moment. 7 plus or minus 4i. Some of you might already know that's x squared minus 14x. 49 and 4 are 53, right? Equals 0. You know the drill. We've been doing this. How do we get there? We subtract 7. Plus minus 4i. If it's a quadratic, we got a square. So there's x squared minus 14x plus 49. We got a square, 16. Did I square 4? I just added 4. So 16 and 49, 65. Boy, I am cognitive decline moment here. So this is negative 16. When I square that, I get 16i squared, right? So that's negative 16. So there's your answer. Okay. Told you if I get in trouble, I'm going to just have to figure it out, find the mistake, and go from there. 2 root 32 is 2 root 16 root 2 minus 5 root 4 root 2. That's where I start. This is 8 times 2 root 2, 8 root 2. This is minus 10 root 2. That's minus 2 root 2. Running out of ink on a new cartridge. Imagine that. All right, so that's done. Next, you know the drill. We've been doing these the first 5 lesson sets. So x equals 9 plus minus the square root of negative 2 over 3. So I'm going to write 2 over 3i. Okay, and that's been explained in earlier lesson sets. What's the range for this? Oh no, range goes to this one. F of x, oh, just point of inflection. So I didn't put that needs some instruction. So we're trying to find the point of inflection. So we need x equals minus b over 3a, which in this case is minus 12 over 6. So negative 2. So negative 2 gets us what? Well, let's find out. Minus 16. So we're going to double that and change the sign. We get 32. That takes care of those two. Minus a minus 2 is plus 2 plus 1. I'm looking at 35, I believe. 35. Yeah, that makes sense because this thing is basically always going up for the most part. I think it's probably always going up. Let's just look at it from c minus 3ah squared. You'll have to do that later in the lesson set anyway. C, negative 1 minus 3 times negative 2 times negative 2 squared. Oh, it's positive 2 was a. All right, so there's my negative 1 minus, it could be in trouble. Negative 1 minus 3 times 8. That's negative 25. Better check this again, take more time with it so I don't have to erase things. All right, so minus b, minus 12 over 3 times 2, 6. Negative 2 is correct. Negative 2 cubed, minus 16. That's correct. So this is going to be positive 48. That's correct. So when I put those together, I get 32. Minus a minus 2 is plus 2 plus 1. I'm still getting 35. C, positive 1 minus, so positive 1. So that was a mistake. No, it was negative 1. C, 3a, that's squared. Okay, I got an issue here. I'm not quite sure why, but I'm not gonna find it right now because I'm at that stage where the old brain's shutting down a little bit. All right, so Yasser, you're up on that one. 25, that's the midline. All right, we're going up 22 units. So 22 and 25, 47. We're going down 22 units, so that's 3. So the range is Y values that are greater than or equal to 3, less than or equal to 47. So that's done. Point of intersection. So that means these two graphs intersect. So x squared minus 2x equals positive 8. So we're going to do x squared minus 2x minus 8 equals 0. So we got an x minus 4 times an x plus 2 equaling 0. So they intersect at 4 and negative 2 for x values. Now we got to plug them back in. Well, we don't have to plug them in. They're both going to give me 8, right? So let's put 4 in to see why. Although it's getting me the 0. Right, that's what I wanted. So, oh, right here, got to plug it in here. Here, 4 squared, 16, minus 8 is 8. Minus 2 squared is 4. Minus 2 times minus 2 is 4. 4 plus 4 is 8. So those are their intersecting coordinates. All right. I'm guessing I asked you to solve this, so I'm going to subtract 8. That gets me 0 equals 5x cubed plus 3x. All right, so I guess I don't want the coordinate here because this is more steps. So this is factored form is x is common, just x. Yep. Times 5x squared plus 3. So the solutions to this are x equals 0 and x could equal, do that one in your head, 3/5, the square root plus minus 3/5 imaginary. I'll let you, we've done a lot of those. So you solve this thing for 0, remember? All right. Woo! Let's keep going. F of 3x, so I got to drop 3x in here. If I drop 3x in here, let's do it out because I'm starting to make errors. I get 6x plus 10. I'm now going to drop 6x plus 10 in for x, and I get 2 times 6x plus 10 plus 10. Final answer, I'm going to write it here, 12x plus 30. There's that answer to that problem. That's doing f of 3x. Boy, I can't wait to see how many errors I make. We'll see. So the ln, this 2 can go there. This 4 can go there. This 1/2 can go there. Right? That's been explained in other lesson sets. Subtraction means division. So I have a positive here, so that's in the numerator. The ln of 4x to the 4th is in the numerator. Y to the 4th is in the denominator. And this is, I moved it, so it's gone. That's the square root of z in the denominator. Now, I haven't explained that too many places, but I'm not going to be able to explain it with this. In order to explain those rules, we got to get to E notation, and that's in previous lesson sets. So I might have to do that one in class some more for you. All right, that's gone. All right, so our widths equal, oh no, I'm looking for the period. So the period of this function is just 2 pi. All right, the multiplier in front of x is 1, and you divide that into 2 pi. So I don't know why I didn't put a number in front of this. I should have, but I didn't. So this is simply the graph. Should I do the graph real quick? Sure. So 1 period, I'm going to put in a 0. Right? If I put in a 0, that becomes 1, so that becomes 3. And then if I let x equal 2 pi, I'm at the end of the first revolution, go che, I'm back to 3. All right. All right. That's done. Hopefully we did justice to the cause in lesson set 26 to lesson set 30, whatever. Y equals 7. How do I get to 17? I add 10. Next time I don't add 10, I go from 7 to 27, which is 20. So this is a base 2 problem. 1970, x minus 1970. And how many years does it take? 30. And most of you are getting those right now anyway. So that's done. Name that tune. Well, I'm going to do it as a sine function still. Could do it as a cosine, a negative cosine, but let's do it as a sine function. All right, so when is the sine function negative or minimum? At 3 pi over 2, which is what I'm spotting. Okay, so therefore, this function becomes the center line, 55, plus 5 times the sine of 1800. I want to have 1800 become 3 pi over 2. So there it is. Pretend there's a parentheses over there. And what am I doing? In 103 years, I'm doing 1 pi, 2 pi, 3 pi. That's that function. If you wanted to change it to a cosine function, well, we could have done a minus sign and made that 0. Or we could have left it as a plus sign and made that plus pi. All of those things should work for that function. All right, we're getting to the graphs now. Name that tune. It's a little dark. Got to go with it. Hope you can see it. I'm seeing a double root, so I'm seeing an x plus 4 squared. I'm seeing a linear root, so that's an x minus 3. I haven't done this, so I'll leave that there for a second. How are you going to get 4 to become an 11? Put the marker. 4 plus 4 is 16 squared. I sure as heck don't want that. And that 16 squared is, 4 plus 4 is 8, sorry. 8 squared, right? And 3, 64 times 3 is 192. And I want 11. Mine. It's really the same thing we've been doing with every other function. Imagine that. I don't think you'll see that in the textbook. Wish you did. All right. That's gone. But it's recorded. All right, so I didn't even finish this one. I was making up a problem. Name that tune. All right, what do I see? 4 is undefined. X minus 4. Negative 1 gives me a 0. So I've got x plus 1. I've got a 3. So therefore, this has to be 3 times bigger. And if I put a 0 in, I want minus 3/4. And yes, 0 gets me a negative in the denominator and a 3 in the numerator. So it looks like I got it. That gives me that graph. All right, now we got a linear function. The only reason I'm asking this is to make sure that folks know that rise over run means that this is divided by 1. All right, so we got a slope of 3 passing through 5, 2. So if I go over a little blue distance, then I got 3 of them. 1, 2, 3. That's that. But I should have done that at the coordinate 2, 5. 1, 2, 5. Well, it's about there. So I can go backwards too. All right, so that's a slope of 3. And it goes through 2, 5. Yeah, that looks good to me. That's this one. All right. Now we've got cup shape down. Yeah, you can see all these. All right, so we're doing this one here, 93. I see a cup shape down because of the negative. I can divide I 0, 7, so 12x increasing through 0, 7. So therefore I'm here, 0, 7, which means my minus b over 2a has got to be positive. So 12 divided by 4 is 3. And if I drop a 3 in, 36 cut in half, 18 plus 7 is 25. So that's that graph. Go back to lesson set 1 through 25 for an explanation. All right, that's done. All right, so I see a slope of 1, not a slope of 1. I see 1 as an asymptote. I'm going up. My first jump is going to be 2. So that means that this is a 3 if I pick whatever makes a 0. And that looks like it's 3, 3. And then I like this thing to equal 1.1. So 5.5 plus 3, 8.5. 8.5 should get me 3, 6 plus 1, 7. So those are a little bit of an approximation there, but it's a quick way to get a feel for the graph. All right, so now we're going to jump over to the other side. Oh, Lord, I hope I don't make a real big mistake right now because I'm not writing all these problems down again. All right, so what do we got? We got a negative. All right, so it should be one of these. Should be exponential decay. And we're looking at negative 3 asymptote. And we're going to plug in negative 2, gets rid of that. Negative 2 gets me a 4. Negative 2 gets me a 4. You take your time with it. And then we want to make this a zero. A zero is going to give me more negative. So a zero is to the right of -2. That gets me the ln of 3, which is 1.1, minus 2.2 plus 4 is minus 1.8. Okay, and I've got backup in case I'm making any errors here. All right, next, we've got a cosine function. All right, I only need one period, so I didn't need to do that. We're going to go one period from here to here, all right, because it's a positive multiplier. And we've got 9 is the center. So that's 9, and we go up to what? 28 plus 9 is 37. And take 28 away from 9, and you got to take 20 away first, which is -1, -11, and another 8, -19, I think. All right, so that, I hope, 19 and 37, 47 and 9, 56 divided by 2, 28. Okay, that checks. And now I'm going to pick 1900. We put 1900 in, we should get 37. Let's do that real quick. 1900, 0 times anything, 0. The cosine of 0 is 1. That's the maximum width. 28 plus 9, 37. So we're home free. 1907 brings us back to 37. And there's your practice for that. Now I got to turn this around, get a little better lighting. All right, Renee, we're almost done. Now we can go home. All right. Graphing x minus 3 over 3x plus 6. You're stopping the video and trying it, I hope. All right, so what do we have? Asymptote at -2. X-intercept at 3. 1/3 is the end behavior. Y equals 1/3. I don't have much room here. Y equals 1/3. Geez, not much room over here. Gonna keep going though. All right, so what do I have over on this side? I've got an asymptote at -2, so I gotta have a y-intercept minus 1/2. So there's 0 minus 1/2. That helps. Gives me a nice frame of reference. I missed that. That's now the intercept. And on this side, I get a sign change because this is to the first. That's to the first. We'll talk about that from different perspectives. The first stages of learning are following anyway. So if you're just doing these for the first time, you're just hearing it, and you can't process it as quickly as I'm giving it to you. But it doesn't matter. We're going to do this 2 minutes a day for the next 2 months. You'll get it. All right. So what's the limit as this goes to infinity? Well, that's 1/3. All right. So if you put 1,000 in here, do the math, and you'll see that you're close to 1/3. All right. So I'm going to not erase this. This is equal to 1/3. Not much time left here for me. So -2 from the right was I've come towards -2, and I keep putting x values into this equation. I'm heading to -infinity. All right, you can try it by plugging in a number like -1.99. That's what this means. Heading towards -2 from above. Numbers that are bigger, moving towards. But visually, it's quicker just to look at the graph if you have it and see what your limit is. All right, so that takes care of this. I got space now, the final frontier. All right, there we go. Oh, when were we less than 0? Less than 0. All right, we were less than 0. You go back and look at the graph. I'm remembering it. We're looking at x values less than 3. That was the intercept, right? We went up from 3. So I got to be less than 3. And it was undefined at -2. That's where we went down. These are the negative numbers. Therefore, we're looking at x values that are less than 3, but bigger than -2. You'll have to go back to the graph, and I hope I'm remembering it correctly. All right, now we'll do another one real quick here. 2x minus 8, x plus 3. All right, I'm seeing -3 as an asymptote. That's where it's undefined. I'm seeing +4. Positive, very similar graph here. +4 as an x-intercept, -8/3. How about we put 0, -8/3? Oh, I'm really giving you a repetition here, right? Where are we leveling off? We're leveling off at a height of 2. right? If you get rid of, as we go to infinity, positive 3 and negative 8, if you've walked 1,000,000,000 miles, walking another 8 is not gonna bother you. What does 2x divided by x become? Y equals 2. The bigger we get for inputs, the bigger the input, the closer you're gonna get to positive 2. Once we get past that x-intercept, you start putting more numbers in there, bigger numbers in there, woo! I suppose you could say as soon as we're to the left of negative 3, as you keep putting numbers in, they're gonna level off at y equals 2. All right. Absolute value, positive, absolute value, V-shape up, slope of negative 4 on the left, positive 4 on the right, passing through the point negative 3, 1. I like the y-intercept, so I'm gonna plug 0 into the function as a frame of reference. I get 13. All right, that's done. Most of you are getting those right already anyway. All right, so that's done. Now I got some room over on the right side. I've been asking you to find coordinates, graphs like this. So I hope you can find some coordinates. And if you do, you're gonna see that it looks like this. All right, so if I put 2 in, my y values have got to get me something that's up here and down here. And what goes with that? What makes it 10, 6, and negative 10, negative 14. And if I put in a negative 4, my altitude is not going to change. This is also negative 4, right? And therefore, what x can I plug in? Something that makes 6. Well, that's an 8. And something that makes negative 6, that's negative 4 as well. What's the center? 2, negative 4. Hopefully I did not make any mistakes there, because when I get to the end of the videos, I start getting really careless. But I'm not feeling that fatigued at the moment. So x equals 5. So we did this one. That's gone. We're doing this one now. X equals 5 is a domain restriction. So x equals 5. I need numbers bigger than 5. And it's a base 2. So that's the inverse of growth. So I'm going to plug in a 6. And then I'm going to plug in a 7. And I hope you look at that and say, why did you do that? Because it gets me quick answers. 6 gets me 2. And then 7 gets me 5. 7 gets me 3 plus 2. All right, you just throw those in there. You should get that for an answer. Yasser to back me up. And I don't care how many careless mistakes I make. We're getting some good practice here. See an exponential doubling. So y equals 1. My first jump is going to be 8, which is going to take me to 9. What number do I plug in? I plug in a 3 to get 9. I'll plug in a 4 to get 17. So 3 gets me 9, 4 gets me 17, and I'm looking at that, and I think I'm done with that one. Okay, so let's get that out of the way. You're stopping the video and trying the next problem. I'm seeing a sine function with 4 as the multiplier. So 2 pi over 4 is going to be the period. So I'm going to start from here to there, and I'm going to go from positive 2 to 2 plus pi over 2. And that's going to get me a height of 6 plus 3. That's a 3. So that's going to get me a height of, oh, okay. So 3 is the midline. So each of these is going to get a 3. But it's nice to be able to find what height your maximum in, which is 9. What's your minimum? 3 from 6 is 3. 3 plus 3. Oh, so I'm changing by 6. So negative 3 is your minimum. Negative 3 to 9 is your range. But 2 plus pi over 2, let's put 2 plus pi over 2 in here because this is fairly new material. 2 plus pi over 2 times 4 now, multiplying by 4. Well, that becomes 8. 8 minus 8 cancels. And 4 times pi over 2 is 2 pi. Goche, the end of the revolution. Oh, we're basically done. You're going to estimate the sine of 1. Okay. Pause the video. I'm going to give you some numbers to work with. I'm going to give you 0. I'm going to give you 1.57. I'm going to give you 3.14. Get out of the way there, you. 3.14. I'm going to give you 4.71. Hope I'm remembering these well. 4.71, and I'm gonna give you 6.28. And 0. And I want 1. Well, 1 is somewhere between these two numbers. What does 1 represent? 1 radius length. Well, that's 1. 1 is about 2/3 of the way to 1.57. 2/3 of the way, pretty close to 60 degrees, which I'm hoping you know is root 3 over 2, which I'm hoping you know is 0.87. So that's a little bit, 1 is a little bit less than 2/3, so I'm right about there. So what's my height? I don't know, 0.84, 0.85, somewhere in there. And that's an approximation for the sine of 1. Boy, I was too far away, Renee. Renee, you were too far away. Hopefully people can, modern technology, maybe you can make that a little bigger. All right, so that was a lot of problems. And, still talking rather than just looking at them and writing answers. So we want you to get to the point where a bunch of those you can just look at and not have to work too hard. 2 months to get that done, right? This is basically your final exam. And I just want you to know it going into your next class. So I'm not hiding anything from you. And I'm giving you as much time as possible to work on as many problems as possible. And if you have this down, you're already in great shape for pre-cal. You could probably get away with it. Probably get away with a calculus class with this foundation. All right, but yeah, there's a lot of other problems in Algebra 1, Algebra 2, and pre-cal we might not be getting to, but we're getting a solid foundation because we're doing it so many times, you're not going to forget it. And what kills a calculus class is when the teacher realizes that the students don't have any foundation to study, to base the study of calculus with. That's what happens. And that's where everybody drops out. So we're over-learning this material. We're going to do it every day at the board every day. And I'm going to try to get you a lesson set every 2 days now, because we're probably going to have to do odds and evens with each of these lesson sets. Probably take 2 days to do it. So that's kind of my guess as to how we're going to move forward. All right. And we still got to stay safe and warm here. My goodness gracious. It was sleeting all day. So icy roads and everything. It's supposed to be spring, I think. All right. Look at that. Nice cowlick and everything. All right. We'll keep working on it. Getting old here. Have a good one. Stay safe and warm.